Howdy folks! We just added the ability to store refresh tokens in Redis. Today, let's take a break from the main application features to learn how to create our first gen middleware. I also wanted to mention that I made 2 updates in the main branch of the repository for more easily getting the application running for newcomers to the project. The steps to run the project have been updated in the README as well. First, I decided to add this .env.dev file to the repository. For development, I don't plan to include any API secrets directly in this file. Later on, we'll reference a Google Cloud configuration file here, so you'll need to make sure to keep that configuration file secret, as you'd always need to do. Next, in the project root in the make file, I added a rule for initializing the application called init, so that the user can run make init and run all of the database migrations. This init file will also create a dev and test key pair so that you can create your access token secrets. Hopefully, this will be useful for anyone who's joining along in the tutorial halfway through or later on, so that they don't have to go back and learn all of the configuration from scratch. Here's the old diagram of what we plan to work on today. If we look here at the right-hand side of our middleware, we see our application layers. The handler layer and all of its methods receive this gen.context. This context is provided by the gen engine for us and gives us access to things like the request, its headers, its bodies, and the response, as well as a whole bunch of utility methods that make working with requests of various HTTP body types and response writers pretty friggin' easy. The problem that we're trying to solve is that if a call to this handler and everything to the right takes too long, what I'm saying is a handler could end up running indefinitely and block the application. So we want to set a time limit for these calls and send an error once that time limit is reached. We're going to be able to do this with the aid of the built-in context library or package from Go. We'll use the context.withTimeout method to wrap the request.context. When we wrap our request context with a timeout, we're going to get access to the context.done method, and this method returns a channel that's closed when work done on behalf of this context should be canceled. And you see that this context is forwarded to all of our layers. In the case of using with timeout, the context will automatically be canceled for us after the amount of time we pass into this with timeout method is reached. I also added some comments on a timeout writer here, and we're going to go into great detail on that later. I'm back in main.go of the application now, where we set up our HTTP server with a handler of the gen router or gen engine. Some of you familiar with HTTP server might be wondering, why don't we just set a read timeout or a write timeout? Why do we have to do all of this middleware stuff? Basically, these timeouts are concerned with the time to read and write the body to and from the client, so they're more of a networking or more of an I/O issue. These timeouts will do nothing to stop long-running handlers. Looking back at the diagram, our goal is going to be to manipulate this request context extracted with the .request then .context method. I'll reiterate that the gen context and the request context, which is extracted from the gen context, are 2 different things. This can be a little confusing, but you may remember in our cleanup tutorial that we made sure to extract the request context and then forward that on to the service layer, repository layer, and possibly data sources. I've now opened up Gen's GitHub page and documentation. To create a custom middleware in Gen, we create a function, it could be called anything, that returns a handler func. You can see here that a handler func is just a function that receives a reference to the gen context. This is great because it gives us access to the context, which we're able to modify according to our needs. In this example, you can see that they use the context set utility method to set a key of example with some value. Another example might be to set a user on these keys or to extract their permissions. In fact, we're going to do that later on. After this set key is called, the c.next method is invoked, and this will call subsequent middlewares or handlers, which are all really just more handler funcs. For today, we're going to create one of these and pass it a time limit and the error that we want to send to the user if that time limit is exceeded. And we also want to handle possible concurrency issues that can happen if a context is timed out. Now, to use these middleware in Gin, we can apply them in a variety of ways. The first is we can take our Gin engine here and apply it to all routes using an r.use and then calling the middleware function. In this case, Gin is going to apply a logger to all of the routes. And by the way, this logger and recovery are automatically added to Gin if you use the gin.default, which we did, which is why we get the nice logs. There's also the option to add middlewares per route. So for example, if we call get on the benchmark API endpoint, then you would invoke the bench logger on that specific endpoint. But the option that we're going to use is to create a group and then on that group call the use method with our desired middleware, which in our case will be a timeout handler. Back in our application, if we go to the handler file, which is in the handler folder here, we see that we already have a group, so we'll end up using a g.use statement and then calling our middleware inside of it. So I just want to mention why we're going to make our own middleware. In doing so, I want to reference 3 middlewares that sort of inspired me and helped me to make the one that we're going to end up using. The first is the standard timeout handler middleware that comes with Go. This is part of the NetHTTP package. The downside to this handler is that it's not configured to directly work with the Gingonic framework. Another thing I didn't like about this handler is that it's configured to send an HTML response in the case a timeout is reached instead of JSON. And so you would have to fork this and modify it anyway to get it to work according to your needs. The second repository that I found is this GinContrib library or group of middlewares and timeout. This is not to be confused with the Gingonic/contrib middleware grouping or repository. This one is not the official group of middleware. I found that this middleware would try to overwrite the error response with a long-running handler's response. And what I mean by that, let's say we set a timeout of 3 seconds, and then the actual response took 5 or 10 seconds. Then what would happen is we would get the error response after 3 seconds, and then at 5 seconds, you'd get a panic saying that our response headers and response body tried to get overwritten by the actual response that took a long time to come in. Now, Gin handled this panic, the person had that set up, but I'd like that panic to never happen. Also, this middleware and the native Go HTTP or NetHTTP package middleware required you to apply them to each individual route. I'm sure you could tweak this, but then again, you're going to have to tweak it and fork the repository anyway. The best one I found that might work for most of your needs is this Vern or however you say the name. It looks French to me, so I probably can't pronounce it, is this Gin timeout middleware. It worked. It handled the concurrency issues. It did not try to overwrite responses. The only thing that I didn't like about it, and it's not even really a reason to not like it, it's that it had these hard-coded JSON errors that came back with code, EO5 as a string, and a message, and I just kind of wanted to tweak that. But I will say that I used this and the NetHTTP timeout handler as inspiration for handling concurrency and what we'll do today. So these are both good for their cases and work just fine. Nevertheless, we were going to have to tweak any of these 3, so I said, hey, let's take this as a learning opportunity and build our own friggin' middleware. Let's now create a fake delay in one of our handlers so that we'll be able to test a long-running handler. Right now, we have this unused sign-in handler, so let's just add a sleep statement to it to demonstrate a long-running handler. We'll let this handler sleep for 6 seconds before sending the response. I also want to update our model layers app errors package here to add a special error for when a service is long running, and we're going to add an HTTP 503 error, which is a service unavailable error. First, we'll add a sort of const type here called service underscore unavailable. And also, I just noticed that I wasn't using any underscores between the words, so let's just add some underscores here to say bad underscore request and so forth, except for un is one word, and we'll say unsupported media type. Alright, those names look a little nicer. Further down here, we have a method called status, which acts on the error, and then it determines the type and returns the HTTP status code according to that type. So let's add a case here in roughly alphabetical order called case service unavailable, which will return this status service unavailable of 503. The last thing we'll do is add a factory function for instantiating one of these errors. Let's go way down towards the bottom and add it penultimately, or second to lastly. And I don't need this comment, but this basically will then just return an error saying service unavailable or timed out. And somehow I added an extra parentheses here. Okay, looks like our errors are ready to go. I also want to make sure that our timeout is configurable via an environment variable. I struggle to say environment variable. I don't know why it's so hard for me. So, in alphabetical order here roughly, we'll add handler underscore timeout and set that equal to 5 for now. Now, in reality, I encourage you to maybe set a different timeout for different types of handlers. As an example, you might have a handler that just updates a user's name, which is just updating some text. That should be fast. And you might have another handler that needs to access Google Cloud or something. So that would require a longer timeout. But we're going to keep it simple here and just say, hey, we can take 5 seconds for all of our handlers. We need, though, to be able to read in this value inside of our handler layer. So let's go back here and let's add a field on the config that will end up taking in this value. We'll call this config value timeout duration. We'll eventually take the value from this config inside of the new handler function and pass it to our middleware, which we'll call somewhere in this area. But first, we need to be able to load the environment variable, and we usually do this in package main in injection.go. So let's scroll down here. This is where we instantiate the handler. We use that new handler factory. And let's, just above this, read in the environment variable similarly to how we did for base URL here. Okay, here we have a variable called handler timeout. We read in the handler timeout environment variable. We parse that as a 64-bit integer. And if there's any error, we send that to the user and we don't launch the application. And then we pass this timeout duration to the handler as a duration. So we're going to take that value, HT here, the integer value, and we're going to cast it as a duration. And a duration is just a 64-bit int. And then we multiply that by seconds to make sure that we get the duration, and it's actually in nanoseconds, cast as a 64-bit integer. And that's what we'll pass to our timeout duration here. After quite a preface, let's go ahead and add our middleware code. Our middleware will be added to a sub-package of handler in a folder called middleware. So a package will be called middleware. And then inside of this, let's go ahead and add that first middleware called timeout.go. And as always, make sure to include the package name. Now let's add the signature for this timeout middleware and make sure it's exportable with a capital letter. This middleware will accept a time duration, which will be received from that config eventually, and will also allow it to receive the actual app error or one of our app errors to send to the user in case of a timeout. We just define that error. And of course, we return a gin handler func. So I just decided now to go ahead and add all of the code and walk through it step by step instead of adding the code bit by bit. We first create something called a timeout rider, which we're going to go over in great detail later. This timeout rider will receive the default gin rider off of the context C here. We'll also instantiate some headers with the sort of base default HTTP header. We're then going to assign to the GIN writer our custom writer, or our custom timeout writer. This is a little confusing, but the concept is that GIN will call the methods on the timeout writer instead of directly the C writer. This timeout writer will store the state of whether we've received a timeout already or whether we've already written a response. We then extract the request context, as we mentioned earlier, and wrap it with this context.withTimeout method, assigning the timeout duration to it, and we defer the cancellation here. When cancel gets called at the end of this function, all resources associated with this context CTX will be freed up, and that's the desired effect we want when the handler successfully completes. Then after deferring the cancel, we set the context request to this new request context that now has the timeout. So it's a little tricky how you have to do this. You have to create a new context and then create another one using with context. But that's just how this works. You get used to it after a while. We then create a couple of channels and send values into them. We have a finish channel, which will receive a signal or a value if a handler has successfully completed. And then we have a panic channel that will receive the value of a panic in case that happens. We then create and then also invoke a go function here. This go function defers the calling of a panic handler, and this is just the default way that you handle panicking in Go with this recover function. If we are able to recover successfully, we're going to send the value of the panic into the panic channel to handle later. Actually, we're not going to use this value, but we do need to send something into this channel. This, of course, is deferred. The next thing we do is call context.next, and this is a GIN method that calls subsequent middlewares and handlers. If this c.next completes, so it's blocking here, but if the handler completes, we then just send an empty struct into the finish channel, and this is how we'll be notified that our handler has successfully completed. So this is running in some concurrent Go routine. And then after this, we're going to create a select statement that will listen to the panic channel, the finish channel, and then the context.done channel, or the channel returned by calling context.done. This context.done will automatically be called for us once our timeout duration is reached. So this is the case of a timeout. In each of these cases, we're going to end up using the tw.response writer and write the response on that. Notice that this response writer is embedded inside of our TW, which is the timeout writer. Again, this is confusing, but hopefully it will become clear as we go through the timeout writer. Here, in the case of a panic, we're going to simply create a new internal server error and then write the header of our response writer with the status of that error, which should be a 500, and send this as JSON using the write method and then marshalling a body of the error. In the case that we finish this handler successfully, we're going to lock this timeout writer with a mutex. We'll maybe talk about that a little more later. After all of the steps complete, we'll then unlock the timeout writer struct. And what we do is basically access all of the headers on this timeout writer. And then we're going to copy all of these headers using this for in range statement here. Doing that, we're going to copy all of the headers from TW, meaning our intermediary timeout writer, to the actual response writer inside of the timeout writer. We'll then relay the code from the timeout writer into the response writer, and we'll do the same with the body. This wbuff will end up holding the response body, and then we use that response body to write to the final response writer. We then have the done case, which is the timeout. We again lock the timeout writer. And in this case, we're going to create a header saying this is application JSON, and we're going to write an error timeout here. Now you might be saying, what is this error timeout? This is that sort of default error that we ended up passing to our middleware function here. We'll then create an error response with an error key and marshal this and write this response. We then use c.abort, and basically this prevents any subsequent handlers or middlewares from running. And then we indicate to our TW structure or our timeout writer struct that we've had a timeout, and this will set a timed out variable on this struct to true to let us know or maintain some state that we've had a timeout. Now, all of this is probably really confusing. I probably did this out of order. Again, we're taking the timeout writer and calling a writer in it. I kind of alluded to the fact that this timeout writer is sort of an intermediate writer that will let us know if we've received a timeout or not. So here is the actual timeout writer. This writer implements a standard HTTP response writer from the NetHTTP package, and that is because it has a write method. It also has the write header, and then it needs one more, this header method, which returns a header. And again, if you recall, we replaced our gin writer with this timeout writer. Basically, what's going to happen is say that in this handler layer, we end up calling this timeout function, and let's say that our timeout is actually 7 seconds. We're going to then call c.json successfully. So when this c.json is called, it's actually going to call our custom writers write header, and header methods to create a response. Going back to timeout, it's going to call the methods write here and write header and header. As an example of calling this header or perhaps this write header function here, let's say that again, this is calling c.json. It's going to write a header with a content type of application.json. And so that will happen here. However, if we look at this write header, you see that first we have a little function to make sure that the HTTP code is between 100 and 1000. But the main logic is if our timeout writer, note that it has a field called timeout or wrote header to indicate if these have already occurred, if we've already timed out or written a header. So if that's happened, we're not going to write a header. And this is what is going to prevent us from writing a header 2 times. But if they haven't been written yet, we're going to call this little utility method that's package private that sets wrote header to true and then sets code on this struct to the code. So it's going to relay the code from c.json, which would be a status 200. It's an OK response. It's going to put the 200 in our tw.code. Furthermore, it will use the write, and in this case, it's just going to write this sort of response body with hello, it's sign out, or actually, sorry, I skipped. Hello, it's sign in here. So that will be written to the body. And if we go to timeout, actually, I misspoke. It's actually going to check if we've already timed out. If we have already timed out, we're not going to write anything. And we're going to return that 0 bytes have been written, that's this int value, and that there's no error. We're just going to do nothing. But if we haven't timed out yet, we're going to take this wbuff here, and that's on our timeout write struct. Where is it here? Here we go. This is a 0 value buffer, and it's empty and ready to use. So we can just add this to our structs. So what we're going to do is write that JSON response. Again, if we go back to handler, we'll write this sort of serialized JSON to our buffer. So wbuff will now hold that JSON. So you see this kind of temporarily holds the data, and then ultimately we're going to use this writer inside of our timeout writer to send the data to a client. So this timeout writer is sort of an intermediate writer. Note that in all of these cases, we're making sure to use something called a mutex from the sync mutex package or from the sync package. And what this does is it prevents multiple concurrent routines from writing to our timeout writer struct. So only one can write to it at a time. So this would prevent any sort of data race if perhaps both of these handlers finished at the same time, or in other words, if the timeout occurred at the same time the handler completed, maybe you could have some data erase. This isn't the most dangerous structure I've seen where you could have multiple writes to it. Nevertheless, this is a good thing to do. All right, so that was a lot to talk about, and this is going on longer than I thought. Let's now go ahead and apply this middleware by calling this timeout function on our handler group. So let's go back to handler here, and we have this group, and let's add a statement to apply this middleware to this group G. This statement maybe isn't as simple as it would seem. We're going to make sure that we're not in test mode, and if we're not in test mode, if we're in dev or prod, we're then going to use this middleware using g.use, and then the middleware.timeout, this is our package, and we pass in the duration from the config. Remember, we added this earlier, and then also the app error that we want to use in case of a timeout. If all has gone well, we should be able to change up one directory to the project root and run docker compose up. Probably I'll have an error, have to come back and fix it, but let's see. It would appear that we were able to initialize our data sources and connect to our databases, so that's good. Here's our handler. Let's go to Postman and see if we can request this sign-in handler. Here's Postman. I have a post request set up for the account sign-in. Let's send this. 1, 2, 3, 4, 5. I guess I could have made that shorter for demonstration purposes, but great, we got a service unavailable. Let's go back to our handler and now set this to something like 1 second. So now our handler is only going to take 1 second to complete, which is less than 5. And let's make sure we get the actual response. Let's send it here. Good, it's sign in. It took almost 1 second. And then let's actually go back to our file here, our log, and let's make sure we didn't get duplicate responses or a panic. And as far as I can tell, it looks pretty good. One more time, let's run the failed case. Let's go back to the sign-in and set this to 6 seconds. And I want to make sure that there's no response overriding going on here. So we send a request to sign in. Should take about 5 seconds. I should have done this one. I'm wasting precious time in your life. All right, service unavailable. And let's go back to our console and see, okay, we got a 503, and there's no panic. It seemed to handle this just fine. It looks like our middleware is doing exactly what we expected. Now, that was a relatively complex middleware. It took a lot longer than I thought, but next time, this tutorial will be a bit shorter. If you're like me, when I was learning from others' work, this whole timeout writer may be a little confusing, and you may have to stare at the code a little bit until it clicks in your head. I hope you consider checking out the written tutorial, and that way you can look it over and think about it a bit. But hopefully I've at least expedited or shortened the amount of time that you have to sit around staring at code, even though I may not be the best at explaining this. Next time, we're going to get working on the actual sign-in handler, not this fake little one, and we'll repeat a lot of the patterns that we already saw when creating the sign-up handler. We'll create a unit test. So that's why I'm saying next time should go a bit faster. So thanks again for joining me. Ciao, hasta pronto.